Hey, welcome guys. Yeah, so today let's solving this 413 arithmetic slices. Okay, so integer array is called arithmetic if we consider that these three elements and if the difference between the two consecutive elements is the same. So basically this is just arithmetic progressions, right? So their difference is both 2, both 0, and both minus 4. And return number of arithmetic subarrays. So subarray is a contiguous subarray of the array. 1, 2, 3, 4. Yeah, contains 3 because 1, 2, 3, 2, 3, 4, 1, 2, 3, 4. So by definition, only 3 of them. At least it needs 3 of them, right? Okay. And this problem can be solved by using a dynamic programming. Okay, so I already write down two boundary cases, which is very trivial. One is if your length is less or equal to 2, then by definition you don't, right? Because at is 3, so you should return 0. If you have 3, then there's only case, right? ABC. So hopefully the middle term is the sum of the 2. Otherwise, you return 0. Okay, so how to solve this? So my definition, let's just write dp. So let's define dpi. Let's say, right, this is your array, right? So this is I. Let's say index is I here. So dpi is the arithmetic progressions. So let me just write down. So dpi defined to be the number of arithmetic progressions. So the problem is that you need to make sure that it didn't overcount the arithmetic progression, the arithmetic subarray. Okay, ending at I. Okay, so hopefully you believe it is just definition, right? The arithmetic progression subarray ending at I, right? So there is something here. And so your answer, right? Your answer will be summation dpi, right? Okay, so from your I to 0, I from 0, let's say to the final. Okay, so to the final. Okay. So our goal is to find the recursion, of dpi. Okay, so I think once you get it, you just need to like a mathematics, right? You just solve it. You just write down a definition and go through array and solve it. Okay, and it's very obviously that how we can find it, right? So let's see. Let's say what is here, right? So this is I and I plus 1, right? So obviously that the dp I plus 1. So there is a case that let's say this is x and y, right? So this is z. Okay, so obviously that there is a case that these three forms arithmetic progressions. So basically, y minus x is the same as z minus y. So this is the same as 2y equals to x plus z. Okay, so if 2y equals x plus z, then the arithmetic progression, so dpi plus 1, should be the same as dpi plus 1, right? So this y is a number of nums of I, and this is nums of I minus 1. This is nums of I plus 1. Okay. What else? Right. I think this is obviously okay, because any arithmetic progressions ending in here must use this previous one as its the previous term, right? So if it can be extended, then anything come out with here can add 1. Else is dpi, just the I plus 1 is the same as dp. Okay, so now you just go through array and write down this equation, then you get the answer. Okay, so now you just need to write down your solution, right? Your dp equation, and you need to start from here, right? So you need to check that where these two is the same as 1 plus 3, right? So you start from here. So you first start from I range from 1 to, let's say, length of the nums of minus 1, and if nums of I times 2 is the same as nums of I minus 1 plus nums of I plus 1, and your dpi will be the same as, or dpi plus 1 will be the same as dpi plus 1, right? That's it. So final, your rest just equals to what? Sum of dp, right? As I expected. And yeah, this is the code I previously rounded. So you can just, let me just run again. and check. Okay, this is the same, and then just go through submit. Yeah, that's it. So see you guys next videos.